In this video we're going to take a look at a couple of ways to organize your Angular tests. Testing is more of an art than a science, so these aren't hard and fast rules, but this video will provide you a good default way to organize your tests, one that naturally leads you to write easier, maintainable, and meaningful tests. The two biggest items to test are services and components. Testing services should be familiar to most developers, since there's an API to interact with. Testing components may not be as natural to unit test since they also have a UI part to them. For services, you want a shallow structure. In this model, you describe a method or property, and then check its behavior and expectations in the same test. Multiple behaviors and expectations would appear at the same base level. The structure of the test suite remains shallow, regardless of the number of tests. This structure can be used for other elements which don't have a UI. For example, let's say you have a file that exports a function foo. You would then have a test file with a describe for foo and tests for what it does. Maybe it returns false when called with an empty string, and it returns true when called with a non-empty string. We can continue adding tests, but they're all going to be at the same level. For components, you want a deep structure. As we mentioned in our last video, called Don't Test the Code in Your Angular Components, you want to test the user experience, not the code. So in this model, you describe actions, check the state of the world, perform another action, check the state of the world, and continue. This creates a tree of actions where the leaves are the tests. For example, you could start with a describe to render the component, check the initial state, then click a button and check the state of the component. At the same level of the click we could add another branch to type into a text box instead. These may look like integration tests, but they're not. We're isolating the component and testing it separate from the rest of the application. Let's see this in action on a real component and service. This is the application we're going to test. It has one component to display images and a service which fetches the data. We can change the number of images per page, and the application waits a second before updating the screen with the new set of images. We can change pages, moving forward and back. We can click on the images to select them, and they stay selected as we move across pages. If we click on a selected image, it deselects it. Now let's look at the code that powers this. The API service is simple. It has a method to get the images as an observable, of course. It uses HTTP client to request some images from Unsplash, and then converts the response to an array of the image type. For reference, the image type is just an interface for an object with an ID and a URL. Back to the API service, it also has two methods to save and retrieve a collection of strings from the local storage. These strings represent the IDs of the images selected by the user. Let's test this service. To do that, we're going to organize our tests using a shallow structure. We're going to have a describe block for get images, another for save selection, and another for get selection. Inside each of those we'll have test blocks which perform an action and check the state of the world. Here's our test file. We're going to create a describe block for get images. Inside we'll have a test that checks if it returns an array of images from HTTP GET. Let's create another describe block for save selection. Inside we'll have a test that checks if it saves to local storage. And finally a describe block for get selection. Inside it will have a test that checks if it retrieves from local storage. The structure of the tests will remain flat because if we had more scenarios for any of these methods, they would appear at the same level of the current tests. How to write the tests is outside the scope of this video, so we'll just do a quick overview. To test the HTTP call, we'll use the HTTP client testing module. Using it on the tests is a bit awkward, but it's the standard. On the test we have an array of image objects we expect get images to return. The mock HTTP request will return an object of the shape the real one would. Testing save selection is simpler. We spy on local storage, call save selection with a set of strings, and check that local storage sets the item with the expected values. Testing get selection is similar. We spy on local storage so it returns the test value, and then check that get selection returns the expected value. For the component, we're going to have a deep structure on our test files. We'll describe actions and then check the state of the component. The component can start in two different states, with or without some images selected. We'll have a describe to render the component like new, and another describe to render the component with images selected. With images selected, we'll prepare the dependencies so the service returns a set of IDs to select, update the UI, and then verify the component has an image selected. On the describe block to render the component as new, we'll prepare the service so it returns the test data, and then update the UI. This represents the action, render the component. Now we check the state of the world. We have to make sure the component displays the default images coming from the test service. Check it doesn't have any images selected. And that it starts with the previous page button disabled. Now we're going to perform more actions after rendering the component. We're going to click on a thumbnail and check what happens. And we also want to change the number of images per page. Let's start with clicking on the first thumbnail. After the click, we want to verify it selects the image. After selecting an image, we want to click on the same image again, click on another image, and also click the next page button. If we click on the first thumbnail again, we expect the component to not have any images selected. Let's take a moment to see the series of actions which got us here. We started by rendering the component. We clicked the first thumbnail. We clicked it again. And finally verified that it doesn't have any images selected. We repeat this pattern for every interaction the user can have with our component. What do we expect to happen if we render the component, click on the first thumbnail, and then click on the second one? We expect the first and second images to be selected. If we select the first image and click the next page button, we expect the component to show images 11 to 20. The previous button to now be enabled. And for the component not to have any images selected. Remember, the image we selected is on the first page. Now let's click on a thumbnail on the second page. It should select the image. If we click the previous page button, the first image should be selected, and the previous page button should now be disabled. If we click the next page button, the second image should still be selected. Let's see how we got here. We rendered the component. Clicked on the first thumbnail. Click the next page button. Selected an image on the second page. Click the previous page button. Click the next page button again. And finally verified the second image is still selected. Now let's change the number of images per page. If we just change the value to 5, the component should still display the original 10 images. But if we wait a second, it should now display 5 images. As with the service, how to write the contents of these tests is outside the scope of this video, but we're going to show the path to this test. To render the component, we spy on the API service, and make it return an observable of images, which depends on the parameters, the page number and images per page. We update the UI using fixture when stable, since the component uses the forms module. To change the images per page, we're going to use Jasmine's clock functionality, get the input element and set its value to 5, then dispatch the input event to signal the rest of the application this value just changed. Now we're going to advance the clock just under a second, and finally update the UI with fixture detect changes. In the after each, we just clean up Jasmine's clock. We get the images to make sure there are still 10. To wait after 1 second, we just tick the clock 1, to get 1000 milliseconds after the input changed, and update the UI with fixture detect changes. We then get the images, and there should now be 5 of them. And their source attributes should have matching values. Again, we're organizing the tests for our component in a tree of actions. We perform an action, check the state of the world, perform another action, etc. And it's worth reminding these aren't integration tests. We're not testing the application as a whole. We're testing the component in isolation, which makes it a unit test, but it gives us the confidence of a user test. Of course, this isn't the only way to organize your tests, but it's one which naturally leads you to write meaningful tests, decoupled from the code behind. Notice we don't even know what the code for this component looks like. We just need to know enough about its dependencies to isolate the component. That's all for now. If you found this video helpful, check out the Simon Test extension for VS Code. It takes care of the most tedious part of testing components and services, stubbing dependencies. Simon Test analyzes your code and creates the necessary stubs, configures the testbed, and it even generates basic tests. Search for Simon Test on VS Code extensions. Ask your company about getting a license for you and your team.